Compressed air, usually referred as industry's fourth utility. As vitally important as electricity, water, and gas, it is also extremely dynamic and unbalanced. Dynamic, because the requirement of compressed air is continuously varying as per quantity, type, and capacity of pneumatic equipment being intermittently operated in a factory. Unbalanced, because the air compressors lag in responding to sudden air demands, causing fluctuations in air pressure. Every industry has the problem of fluctuating air pressure. Let us understand the root cause for these fluctuations. When supply of compressed air is more than the demand, the system experiences rise in air pressure. Conversely, this pressure fails when air demand is more than the supply. Due to continuous variation in air consumption, there is mismatch between supply and demand, resulting into imbalance that causes the air pressure to fluctuate. Consider a typical compressed air network consisting of compressors, wet receivers, air treatment equipment, dry receivers, air distribution systems, and machines or applications where compressed air is consumed. When there is a sudden air demand due to starting of pneumatic equipment or tool, the pressure at that consumption point drops low. Since this consumption point is away from compressor station, the compressor will notice this pressure drop only when this low pressure signal travels upstream through the distribution pipelines, main headers, air treatment equipment, receiver storage tanks, and finally reaches to the compressor. Upon releasing this drop in pressure, the capacity control switches the compressor to load, or a VSD compressor increases its speed to pump more air into the system. This extra amount of air increases the pressure in compressor station back to normal. In few months thereafter, this additional air travels through the system up to air consumption point to normalize the pressure. The overall time taken to complete this cycle could be from few seconds to minute, depending upon the size of the air system. This trend is repeated over and over throughout the day, and the manufacturing process goes through repeated cycles of pressure variations. Considering a large number of consumers and the localized effect of air consumption, we can imagine the large amount of fluctuation and the actual time lag between demand and supply. Evaluating the above occurrence, what can we conclude? The time taken by the pressure drop signal to reach the compressor and the compressor supplying additional air is larger than the cycle time of the end-use application. By the time the compressor pumps in the required quantity of compressed air into the system, the application has already been completed. Even after the end-use application is completed, the compressor would keep supplying air until it satisfies the set pressure limit. As the system operates at air pressure even marginally higher than required, more quantity of air is consumed by the pneumatic tool. As can be seen, the compressors operate to meet the speculative demand, which can also be termed as artificial demand. When a pneumatic tool is supplied with air at pressure higher than it needs, it consumes more air than it should. This excess amount of air consumed by application is called artificial demand. Let's understand the effect of artificial demand. Consider 1 m3 of compressed air at a pressure of 100 psig. When this air is expanded from 100 psig to 80 psig pressure, it will occupy 1.25 m3 volume. Thus, for an application which requires compressed air of 1 m3 at 80 psig, when we supply 1 m3 at 100 psig, we end up with supplying 0.25 m3 air more, which results to artificial demand. This artificial demand increases with increased air pressure. In industries generally, an air cylinder that is specified to use 30 psig will use 70% more air at 60 psig, 230% more air at 90 psig, and 300% more air at 120 psig. Virtually all air-powered equipment work this way. The more pressure delivered, the greater the air used. Auditors call this phenomenon artificial demand, resulting into higher energy consumption.